Hi everyone. Today we're going to be talking about green infrastructure in cities. And I want to start by just addressing a more general issue that I think is a little bit confusing when we talk about green cities, because a lot of times when we picture urban environments, we picture degraded, polluted, dirty spaces that have nothing green in them at all. And we can be left, if that's what we're picturing, we can be left with the question, why is everyone talking about green cities? Because these don't look very green. So I wanted to actually bring us into this topic by talking about a little bit of a chapter called The Surprisingly Green City that I think helps to acknowledge that is a little bit counterintuitive for many of us. It comes as somewhat of a surprise to hear about cities being green. So I thought we could use Toby Hemenway's work to help us understand this. Okay, so this is how Toby Hemenway puts it. He says, in the 1990s, my wife Keel and I moved from an urban existence in Seattle to a deeply rural one in Southern Oregon. One of the many reasons for this seismic life shift was our yearning to trim our ecological footprint. So they had this idea of, sort of going back to the land, growing their own food, being more self-sufficient, leading a simpler, slower paced life. And they really loved it. So they were thrilled with their decision. And then he says, but after some time, I noticed that there were some things that didn't quite fit my expectations. So they were using a lot more gas in their cars. And the reason was that they had to make a long drive to get their groceries. They were farther away from their friends. And so anytime they wanted to go to a party or have dinner or see people, there was a long drive to get there and to get back. And that wasn't the only thing. He also noticed that there was a road that went to their property, to this remote rural property. And they were responsible for maintaining a quarter mile of this, and that required a lot of maintenance every single year. Similarly, it was very hard to get cable out there. It was hard to get plumbing. There was a septic tank. There were electrical issues. And as he puts it, he says, we lived out in the wild, but our long umbilical cord to civilization used a lot of metal, plastic, rock, and fuel to build and sustain. Okay, so over time, he and his partner decide that they're going to move back to the city. They don't go back to Seattle, they go to Portland. But right away, he notices the difference. It's easy for them to see their friends. It's easy for them to go out, to go shopping. They can walk or bike to a lot of things. There's public transit. And actually, their energy use plummets. And he says, this is not an absolute thing. It would be possible to consume fewer resources out in the country. But in fact, most people in rural areas are not growing their own food on their own property. They're going to the supermarket, and that supermarket is far away, and they're going to work, and that work is far away. So it actually turns out to be a pretty energy intensive lifestyle. And then he mentions this article, which I thought I would throw in here just because it really is a great piece, called Green Manhattan, which is a similar story of a person deciding to move to a more rural area and comparing what it really takes energy-wise to live in the more rural area versus, in this case, the author was in New York City. Okay, so what Hemingway ends up saying about all of this, and I hope this is helpful, is he says, I'm not saying that cities are gleaming exemplars of sustainability. And he says they aren't any more than any other part of contemporary society is a gleaming example of sustainability. However, here is why it may make sense to think about ecological improvements from the point of view of cities. And that's because, as you know, huge numbers of people live in cities. That number is rising. So if you think about it, that's actually because of all the population. That is a great place to start thinking about city form and the type of energy that's being used and how first. The most of the authors who we are studying this week who are talking about ecological urbanism agree that it's a really good idea to sort of fuse urban planning with environmental thinking. And that's generally what is meant by an ecological urbanism. Okay, so when people talk about green cities, when David Owen says green Manhattan, or when Toby Hemingway says the surprisingly green city, what they're talking about is the pattern. When population is clustered tightly, what that means is things are not as spread out. And when things aren't as spread out, it's easier to get places. It's more convenient, more pleasant to walk or to bike. And it also becomes possible to run mass transit systems, which you can't do in more spread out areas. It becomes less economically, it makes less sense. So for all of those reasons, the city is green. And I just want to mention here too, apartment buildings also are more energy efficient than single family homes. You pay less in utilities. Don't get confused about the fact that it is not terribly easy to power an apartment building on solar panels, right? Remember we talked about that all of the units, right, in order for a building in the city to be net zero, all of the units would have to be able to run power from the same set of solar panels. And that is unlikely to happen. But just because the building is not net zero doesn't mean that there is a lot less energy expenditures per capita. So if you're confused about that, ask me. But I wanted to bring that up since we had talked about that. Okay, so great. Cities are green, and yet when we look at cities, they look gray. They are overwhelmingly made of hard materials. So there's a lot of structure in the city, and there's also a lot of infrastructure, and almost all of that infrastructure, for example, roads, sidewalks, is made of concrete. So this actually doesn't look incredibly natural. It doesn't fill us with the delight that nature fills us with. And it has a further environmental impact that is quite significant. Which is that those surfaces, all of those surfaces, and sometimes they're called hardscapes, right? So the roads, for example, or sidewalks, those are not something that water can soak into. So what happens in a city is that actually the hydrological cycle that would have applied in that area is significantly altered, and not really for the better. There is a change made by the fact that there's so much impervious surface. So we're going to talk about this with respect especially to the issue of sewer systems. But I want to point out that it is these impervious surfaces that are also contributing to the urban heat island effect, which you're encountering in your readings. So there's really multiple dimensions on which all of this hardscape is a problem. So while we can certainly think of the city as green because it invites a dense pattern, which reduces fossil fuel use to get between places, we have to keep in mind that there is plenty of room for improvement. Okay, so this little video actually does a good job of explaining what goes wrong with combined sewers in many, many cities in the United States. So it's a little bit disgusting, but I recommend watching that to try to understand that. I will try to explain it as best I can in my own way. This diagram is just helping us to envision when we build a city, how we affect the hydrological cycle. And you can see that part of what is happening, because water cannot penetrate anywhere there's a building, anywhere there's a road or sidewalk, anywhere there's a parking lot, water can't really get in there. So we're really not having very much deep or shallow infiltration. We're really not recharging the underground aquifers under our cities in the way that we would in the environment pictured on the left. What we're also not having as much water be seated and sort of held in the natural environment, allowing it to evaporate over time and then later rain again. Okay, so 40% of the water that comes down is actually going to go right back up, evaporating up into the clouds so that it can be stored there and then rain again. Okay, so that's how the more natural hydrological cycle is working. In the urban environment case, where is all that water going? It's not going back up into the sky. It's not going into the groundwater. Where it's going is it's running off. It's going elsewhere. So essentially what we have is a very precious natural resource that is sort of at a moment in a cycle being diverted elsewhere. Okay, that isn't really the problem though. It is obviously a problem, but the bigger problem has to do with the way that we've built our sewers over time. And this is really true of most American cities that are older, have this kind of sewer. And the reason is that what we used to do with our sewage was pipe it out of our houses into a drain that went into a local body of water. That used to be what we did with our sanitary sewer, was pipe it from our houses into rivers, creeks, bays, harbors, etc. That changed in the modern era, and the household waste, the sewage, for example, when you flush your toilet. Now, and you can see this in the diagram over here in the dry weather diagram. So let's say you're living in this apartment, you flush the toilet, or you do a load of laundry, you run the sink, the shower, all of that comes out the sewage pipe and it goes down along sewer main and then down to another pipe where it's going to go to a treatment plant. Okay, so in dry weather, that works correctly. However, in many, many municipalities, and I'll name some cities for you. So Boston, Philadelphia, New York. I also did a little bit of research today, and I'm sorry to say that San Francisco and Chicago also have this problem. What happens is that when it rains, you still have people flushing their toilets and taking showers. But you also have rain coming down on the roofs of buildings. That's going down downspouts into gutters and adding to flow. And you have all of the runoff from all the other impervious surfaces. So all of the streets, all of the driveways, all of the sidewalks, anything that is paved, you have that water running off. And you have it joining up with the black water from the sewage pipe. If you start having enough volume coming down that storm drain, you will get to the point where the junction between the outfall, where the pipe goes into a local body of water, is called the outfall. This junction between what is supposed to be correctly routed to sewage treatment and what is just going straight out into a river or bay or other body of water becomes overwhelmed. Everything mixes together and it all goes into the body of water. And these events are frequent. It does not actually take a catastrophic amount of rain. It doesn't take a huge storm to create an event where you have raw sewage going into a local body of water. So you could look at this problem and think that it is about aging infrastructure. And I'm showing you this picture of this kind of amazing old brick sewer in Philadelphia. But it actually really doesn't have to do with the age of what's underground. For example, this pipe in Philadelphia is in use. It works fine. What it really has to do with is the fact that at the level of the surface, as our cities grow bigger and bigger, and as our cities are more and more developed, more of the surface area of that place is impervious. So as more and more streets, for example, are paved, if you take an empty lot that was full of weeds, rain would soak into that. If you now build a building on that, that's more impervious area. So every time you build a new building or pave a parking lot, pave a road, and obviously as cities grow and grow, they're doing more and more of this. So this was actually something, these overflow events were not a problem because there wasn't as much runoff. There wasn't as much stormwater, which is what they call the rain that comes down during a rainstorm. So there was, in other words, the rain hasn't changed necessarily, but the ability of the ground to soak it in has dramatically changed in our cities over time. So weirdly, you would think, okay, well, this is like an old problem that we have to fix, but actually this is a new problem that is created by the increase in impervious surface. Okay, so one solution to this would be to say, well, we need to build a much larger sewer infrastructure. We need to have, let's say, pipes that are 3 times as big. So this never happens. Or we need to have holding tanks and reservoirs in certain areas to make sure this doesn't happen. So in other words, the idea here would be sort of doubling down on or increasing the amount of concrete underground in the city to help manage this. But there is actually an approach that has been tried in the last 5 or 10 years that is kind of the opposite. So rather than adding more concrete, rather than adding more gray infrastructure to approach this problem, the idea is actually just to reduce the amount of impervious area in a city. So to reduce the stormwater runoff so that the existing pipes, which had been perfectly adequate for a very long time, continue to work. And as you can see probably from looking at this rendering, that's going to have a host of other benefits as well. And you're really going to have something that actually does look like a green city. So where the Green City Clean Waters program came from was actually that Philadelphia was falling afoul of the Clean Water Act. The government, the EPA standards in 2010. And what Philadelphia did was negotiate a way of approaching, a new way of approaching the remediation of the water quality, which had to do with this idea of taking hard surfaces and turning them into surfaces that could absorb and store and hold rainwater in place. So the picture that you're looking at here is lovely. It doesn't, Philadelphia doesn't look like this from the air right now, but that is the vision of the city. And I just want to point out a couple things. There are places in Philadelphia where they are doing concrete infrastructure, where they are changing the way pipes work, the size of pipes, the way they connect, in order to improve the sewer. In some locations, that was what they needed to do. But for many other locations, they have gone with this other approach, which is more generally now being called green infrastructure. And many other cities have copied it, in part because it is less expensive to do than digging up your sewer and removing it and replacing it with even larger sewer pipes. So I want to talk a little bit about some of the advantages of this green approach, and then I also just want to show you an example or two from Philadelphia and from elsewhere to get you interested in this. And then the assignment is also going to give you a little bit more of a chance to think about this. Okay, so one of the things that is kind of cool about the green approach is that it is decentralized. What it says is, well, everywhere that rainwater falls is an opportunity to hold and store that rainwater rather than to run it off into an overwhelmed sewer. And that allows you to think very, very locally about how you can hold water where it comes down rather than directing it away from wherever you are. So all of the energy that you would have put into directing it, channeling it, and adding it up into this huge volume of water, you sort of do the opposite. You try to keep the water where it is. And this also really facilitates a teensy tiny kind of approach to the problem. So instead of having to think on the scale of a large engineering firm that would bid on a project like this and would have sort of expertise that no one else has, this allows you to kind of do a lot of community outreach and education about letting the community know, hey, it's really great if the water that comes onto your property stays on your property. And there's all kinds of ways to do that. So Philadelphia's version of this is called the Rain Check program, where they kind of give homeowners like a menu of different options for how they can hold even a little bit of water on their property, and providing financial incentives for individual homeowners to do that is just part of their program, right? But the idea is that these tiny little incremental contributions will add up to thousands of gallons of stormwater not entering the storm drains. So it allows there to be lots of little small projects adding up. That allows individuals to participate. It allows community groups to participate. And the smaller scale also is more likely to be something that a local firm can take on a project. And that keeps more of the city budget actually local and invested in the community. So this article, which their local PBS affiliate published, explains some of the advantages from the point of view of the municipality, because those dollars that are, spent on local businesses are much more likely to stay in the local community. So what this also means is, and this is actually really fun to look at. I'm going to click on it right now, and you can play with this at home. But you can see that what you have is zillions of these little projects everywhere. And you can click on them. There is a key somewhere on here. I think it's this. But you can also click on each project to see what was done. So the ones that have this little check mark mean that was an individual homeowner. And then there's also much larger scale projects. So all of it is put on this sort of master map of the city so that people can see what is happening. And of course, they've also had to submit all of this data to the EPA, because part of negotiating the special agreement with the EPA was they had to show compliance and progress. So at their 5-year review, they had actually exceeded the number of individual projects that they were supposed to have completed at that point. This is actually a 25-year plan that the city is engaging in. So the idea is that the city will get more and more and more green at the same time that it gets that it actually significantly improves the water quality in the local rivershed. Okay, so there are many different techniques that are used to manage stormwater runoff and to try to hold it in place. One very popular one is the bioswale, and I'm showing you a couple pictures here. These are not, at all cheap to put in, because although you're looking at it here when it's planted, and by the way, there are of course other benefits, right, to having these nice little almost like mini micro parks on the street. From an infrastructure perspective, what's really happening here is happening underground, right? So you're essentially building a very large vegetated French drain. You'll have some rock, you'll have this long layer of soil. All of this, the plants, the rock, the soil, are all functioning as filtration devices. You have further rock underneath that. This is a way of keeping and holding some of the water. It's also cleaning the water. So there is a lot that goes into creating these. They sort of look like just little street side gardens, but they do actually require a lot of digging, a lot of materials. It's not that they're super cheap to build. They're definitely cheaper than digging up the street and replacing the sewer, however. So the bioswale is one possible way of creating green infrastructure. Permeable pavement is another kind. And I've put 2 links here. One kind of walks you through the different types of permeable pavements. The other talks about when you can use it, because it is not appropriate for all applications. And in particular, if you think about things like porous asphalt, which are really cool in certain applications, like for playgrounds, it is not going to be appropriate, for example, for roadways. Because the reason why it's porous is that it's full of air. And that means it's less structurally stable, which means it can't take a lot of traffic driving over it. So one of the things that Philadelphia did that I think was very intelligent in trying to implement this plan is they looked at where some of the worst problem areas were. And one of them was in this area called Mill Creek. And not only were there severe problems with these sewage overflow events in this area, they also had this old city park that was not in great shape. It had not been nicely maintained. It was in bad condition. So this is the kind of project that the city targeted for the first round of the Green City Clean Waters program. In other words, something that was really suffering, really not in good shape. And here they used a porous asphalt. So this porous asphalt is kind of incredible in that it actually has noise reduction properties. I bet it's nicer on the legs too as you're jumping around on it. But the real reason is it's to take all of this hardscape and make it permeable to rain. So actually there are pictures of people pouring, you can pour a bucket of water on that asphalt, and instead of sitting on the top of it, it will go into it. In this particular case, they actually poured the asphalt over an infiltration bed. So like a rock bed, like you saw in that other cross section of the bioswale. So that's what's underneath this basketball court. So this is a really cool project. Another project where Philadelphia used permeable paving was in this block, and you could see why they would pour porous asphalt here. It's because no 18-wheeler trucks are going to be going down this road. It's too tiny. It's a really narrow, almost little alley. But all of these people were having problems with flooding in their basements. And it actually turned out when they looked into it that there was a broken sewer under this road. So all they really had to do here was fix the sewer, dig out the road, fix the sewer, and then they could have put the road right back. But instead, they decided to use porous pavement in this little alley. And again, it has an infiltration bed under the surface. And ever since they did this, this street is completely dry now. So it was actually a problem with the sewer itself. But the cool thing about this is that this has actually improved the ability of this street to hold the water in place, right? Rather than running it into the low areas nearby, like people's basement. So I think this is another really cool project, and I actually put a link to this video as well because it really gives you an appreciation for the porousness of the street. This is one of the ones where they pour the water through, and you can see that this is actually a piece of green infrastructure, even though it doesn't look like it is. And let me just say that, you can see on this street, and the sidewalks are so narrow here that there really isn't room for some of the other kinds of infrastructure. And I think that's another reason that they went for the porous pavement. So if you were really, really doubling down on this insight about impermeable surface as the problem, you would realize that the other thing that absolutely needs to be addressed is the roofs, right? Because it's the roofs that make the buildings impermeable surfaces. And of course, we want those to be impermeable because we want our apartments and our places of business to be dry. However, if you use a green roof, you can actually hold enormous amounts of water in place safely on the roof of your building. And you can also create an amenity for the residents of your building, but additionally benefits for the city as a whole, because having these vegetated roofs goes a long way to mitigating urban heat island effects. So Salzburg, the city of Salzburg in Austria, is now actually requiring this as part of their building code, that every new building have a plan for mitigating its own stormwater runoff. So it's essentially tantamount to saying that new buildings are going to have green roofs. So that's really exciting because, of course, if you think about this, you still have huge amounts of impervious surface here, right? You have all the sidewalk here is impervious, and the roofs of these buildings, which are all very close together with no room for trees or anything, is also all still impervious. So I think it might be helpful to just check out this link. I think you'll like this. It's short, but it just talks about different kinds of living roofs and what you're trying to accomplish. Are you trying to grow food? Are you trying to have solar? Are you trying to do what they call a blue-green roof, meaning use the roof for water storage? So I hope that will help you think about these different options and sort of when those might be used. Okay, so just to end there, the assignment is going to ask you about something to do with green infrastructure, and it's going to give you a case. There isn't a lot of detail in the case, so you don't really need to give a very detailed answer, but I would like you to kind of think through what would be the possibilities for green infrastructure at this particular school if this is the layout of like the streets and the parking lot and the impervious surface of the building itself, etc. So that's the assignment for this week. Okay, thanks everybody.